Push that rock here, Simpson mat. Here we have an equation, and we see we have a derivative, the derivative of y with respect to x, and it's equal to some ratio. Here, we expect y to be the dependent variable of some function, so there's some function here, and then here's an express function here. So what are we doing here? Well, we're trying to find the function y such that if we take the derivative of y, it will equal this linear function divided by the square root of the y function. Okay, so this type of problem is a differential equation. And you're going to take, if you major in engineering or math or some very heavy math field, you will take a whole course in differential equations. So this is a very simple example just to show you an application of integration, because here in Calculus 2 we're studying integration and its applications. So, but there's a whole course in this, and there's a whole long list of techniques. The technique I'm going to demonstrate here is just called separable equations. So we want to get the y's with the dy's and the x's with the dx, and that's what they mean by separable. So I'm going to multiply both sides by the square root of y, and I multiply both sides by dx. Then I'm going to integrate on both sides, and when I do, I'm going to rewrite that as y to the 1/2. And now I have it looking like an integration problem on both sides. Here, I'm going to integrate and add 1 to the power using the power rule. Put the reciprocal out front, and don't forget your plus c, baby. And then over here, let's see, that'll be x squared, put the reciprocal out front, but it's multiplied by that 2, plus that'll just be x, because the derivative of x is 1. And don't forget your plus c, baby. Okay, so we integrated on both sides. Now I'm going to subtract this c from the c. I don't get 0. This is just some set of constants. This set of constants, whatever the constant happens to be, if you subtract a constant from another constant, you still have a constant. I mean, even 0 is a constant, so you think of it as c from c is 0. Well, yeah, it's still a constant. So I have over here x squared plus x plus whatever that constant is. And over here I have 2/3 times the square root of y cubed. Now I'm going to get rid of the 2/3 first. So, and I'm also going to rewrite this as the square root of y being cubed. And then it's this 3/2 multiplied by 3/2 on both sides gives me x squared plus x. And the 3/2 is multiplied by all of these, including the c. But guess what? When you multiply 3/2 by a constant, you just get a constant. Okay. So now I'm going to take the cubed root of both sides. So I have the cubed root of all of this. I guess I could distribute the 3/2. I don't know if it's what's better. There we go. And then I'm going to square both sides. And so I have the cubed root of 3/2 cubed root 3/2 x squared plus 3/2 x plus c, all being squared. And we have accomplished our mission. We have solved for the function that if I take the derivative of this and then I take this and put it in place of this y, and then the derivative of this and put it here, I'll have an equality. And that's how you use integration to solve a separable linear first order, there's a lot of technicalities here, differential equation. Math made simple. Simpson that.